So the last piece of this high-level walkthrough or higher-level walkthrough of the Zippy microservice is finally going to zero in on the ZippyService, and we're going to show how it applies the JPA in order to be able to do these lookups, both lookups that come out of the box with the declarative Spring Data API features as well as the custom implementations that we define. This particular implementation is going to use just a teeny-weeny bit of Java parallel and sequential streams, and then it's also going to use the generated code that came out of the box using the JPA and the Spring Data API. So here's the ZippyService. This implements base service. We've seen base service before. That overrides the methods that are defined in base service to provide ways of accessing the database in this case. And it's going to be parameterized by a list of quote objects using the classic features in Spring Web MVC. Annotate it to say it's a service, nothing really exciting there. This gets interesting. So now we're going to auto-wire the JPA quote repository. If you recall the handy service, it had a field which was the list of quotes, so it was non-persistent, and we wired that together using a bean that would go and extract that list of quotes and convert it into, the file of quotes and turn it into a list of quotes. Now we're going to use the JPA quote repository, and this auto-wiring, among other things, as we'll see when we get into the implementation in a bit more detail, actually will go out and populate this database automagically from a file that contains Zippy the Pinhead quotes. And you probably don't know much about Zippy the Pinhead. It was a very psychedelic cartoon character developed by an artist and a comic writer named Bill Griffith. And he always said these very strange things that were sort of stream of consciousness. And his famous quote was, "Yow, are we having fun yet?" That was what he would say. At any rate, that's what the quotes are. Here's what the getAllQuotes method looks like. Remember the getAllQuotes method we had before for the handy service just returned the list? That's all it did. It just said return M quotes. Well, we're doing something almost the same, except this time what we're doing is we're using predefined methods in the JPA repository that will return all the contents in that particular database table. And essentially, the repository, mRepository is the field that we auto-wired. We say mRepository.findAll. FindAll is written for us. We do not have to write that ourselves. And what this looks like under the hood would be select anything from the quote table. So that's what findAll does. And once again, ChatGPT tells me what that does, and it's very obviously correct. Just for kicks, just to show this off, we're going to make the getAllQuotes method cacheable. Because if you think about it, the list, the table of Zippy the Pinhead quotes never changes, at least not in this implementation, and therefore we can cache it. So by saying @cacheable, that says the first time somebody calls the getAllQuotes method, call this method to get the list of quotes, and any second or subsequent time, don't call the database method, just return it from the cache. So that'll be a server-side cache, helps to speed up performance by not having to go to the database table each time, which might be a win, depends on various factors. So this is how we can make a method in Spring be cacheable by using this annotation. Let's take a look at another implementation. This is the getQuote method. This method takes a quote ID and returns the corresponding quote. If you recall how this method worked for the handy application, the handy microservice, it went and just indexed into the quotes list at that location and returned the element that was there, the quote. We're going to do things a little differently here because we're looking this up persistently. So we're going to say mRepository find by ID. Find by ID is also automatically generated for you. So we do find by ID with the quote ID. That will go look up in the database, and we'll try to find the quote corresponding to that ID. If it finds it, it returns it. If it can't find it, if the ID doesn't match for whatever reason, it'll throw this illegal argument exception. Once again, we're going to cache the quote associated with the quote ID on the server side. Now, this might get a little bit excessive after a while because we'll end up chewing up lots of memory storing all these quotes. But I'm just pointing out that you can do caching at a more fine-grained level than just caching everything. So we're caching it on the quote ID. So the first time someone comes in and asks for quote ID 17, it'll go and make this call. And then the second subsequent times, it'll go ahead and return what was cached. Then this implementation, post quotes, is going to find all the quotes that match the quote IDs. So in this particular case, it's going to take the quote IDs and it's going to use another auto-generated method called find all by ID, where it's going to select from the quote table where the ID is found in the table. So it's going to go look up to find the ID in the table. So that's what the corresponding SQL is. That's what this does. This method is also automatically generated. Notice that everything we've done so far has been making method calls on the repository that we didn't have to write, because either those things come out of the box, or as we'll see, we did write specify some. So this implementation of search, is going to use the find by quote containing ignore case. This is something that we defined in order to be able to go and find a quote that contains the query in a case-insensitive way. So this is what the query looks like. We looked at this earlier when we talked about the JPA repository. This is auto-generated by Spring Data API using what we defined here. And you'll notice what we're doing here, just for kicks, this is just a little teeny-weeny bit of Java, either parallel or sequential streams. Let's see if I talk about that. So basically, we take the list of queries, turn it into a stream of queries, either in parallel or sequentially, and then we use flat map to go find anything that matches in this database. So this will get called repeatedly, and we turn that back into a stream. We go ahead and take all the results of that, so this will be a bunch of queries, and there may have been multiple strings, multiple quotes that matched, so we use distinct to eliminate them, so we only get them once, and we turn that back into a list. So notice what this is doing is this is using Java streams in conjunction with find by quote containing ignore case, which was auto-generated, in order to be able to get a list of quotes that match any of the queries in the queries string. So we didn't totally make this code something that could be done by the database, but we did do it like this. The last piece of the puzzle here is the searchEx method, which, as we saw before, tries to match anything that is in there, or sorry, everything that's in there. And in this case, we're actually going to call the find all by quote containing all in method. And that's the one that we wrote. So this is actually a custom query, and it will go and it'll return anything that matches all the queries. So if we find stuff that matches all the queries, we'll get results. And when we run the client, you'll actually get a chance to see that there are things that match like that. So this shows you a whole bunch of different ways of doing this stuff, ranging from entirely using generated code, like find all, for example, or find by ID, or find all by ID, or hybrid code where we have some code that we have to write programmatically in a declarative way, of course, using Java streams. And then we combine that with stuff that's automatically generated by Spring. And then we have other code shown here where we push everything into the database layer, except now we had to write this custom query. So super powerful, very comprehensive in showing off a whole bunch of different features, some of which are written programmatically, most of which are generated declaratively, and some of which do a little of both. So that's the end of the fourth part of the overview of the Zippy microservice, showing you the richness of how we're making it persistent and integrating lots of different features.